In this video, we're going to show electron dot structures along with their corresponding shapes in 3D. And we're also going to show an example of something that has a double bond as opposed to everything we've done up to now is having single bonds. I'm going to grab a marker and let's go to our first examples. This is examples 5 and 6 on page number 7 of your homework packet, I believe. And we're going to work with that now. So let's say it's something like C2H6. So again, I could look at the chart and see that carbon is in family 4. Maybe I'll grab that real quickly and look and say carbon is in family 4. It's going to have 4 valence electrons. And I know I stuck hydrogen over here on this, but hydrogen just has 1 electron, and that is an outer shell or a valence electron. So if I do my count of electrons, when I do this, I have 2 carbons. 2 times 4 would be 8 electrons, and 6 hydrogens. 6 times 1 would be 6 electrons for a total of 14. All right. Then, so I'm going to do this structure, and let's see. I'm going to draw it, and I start with a 1. Usually it's the first one, and the one that bonds the most. I'm going to start with one of these carbons, and I'm going to draw its first electron here, and then go around the horn, first, second, third, and fourth. Okay. Now the thing is, do I put another hydrogen next or do I put carbon next? Hydrogen and halogens only have 1 bond site, so they can never be the cheese. They can never be sandwiched between something. So what I want to do is go to my other carbon and spot that first. Okay, and maybe I'll change my color marker so we can see this a little better. And I'm going to put a carbon, and I'm going to put 1, 2, 3, 4 electrons around that. Okay, now I'm looking, I got, okay, the carbon's bonded to a carbon, 2 bonds, it could be a stick. I got 1, 2, 3, 4, 5, 6. I got 6 places for hydrogen, and I have 6 hydrogens. So I can just fill in the hydrogens at this point. I suppose I can grab a blue. Let's go over do that. And I'm going to put a hydrogen here. Okay, and this might take a while. Be a lot easier with a pencil. And I'll put this here, and that's going to match up. I suppose I should do things the same on each side, but I'm pretty confident this is going to work out. So there's my third hydrogen. I'm going to go to my 4th hydrogen. My 5th hydrogen. And my 6th and final hydrogen. And I look at this and I go, okay, I have 2, 4, 6, 8, 10, 12, 14 electrons like I'm supposed to have. I have 2 around this hydrogen, 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 2 around this hydrogen. So that matches. And I have what? I have 2, 4, 6, 8 around this oxygen or carbon, and I have 2, 4, 6, 8 around this thing, this carbon here. So it looks like I got an octet around everything. This looks like it's a stable structure. Okay, what's the difference between 2.5 and 2.5? It's 0. Well, I know that is NPC, nonpolar covalent. 2 of the same things are going to pull with the same force. Okay, what about between 2.5 and 2.2? What's the difference? It is 0.3, and I believe we said, even though that's slightly polar, I believe we classified that as nonpolar covalent in our little chart. Let's just double check that quick. And I believe 0.3 still qualifies as less than 0.4. So we'll say that's nonpolar covalent. Polar, and notice it's a matter degree, but the polar character is really small. So we're going to classify that as nonpolar covalent. So we got NPC for both of those right here. Okay, I think that solves that problem. What if I get the question, how many bonded electron pairs? 1, 2, 3, 4, 5, 6, 7. How many? 14 divided by 2 would be 7. There are 7 bonded electron pairs. There are 0 unbonded electron pairs in this structure. How would this look in 3D? It looks similar, except you would see that this structure is a little bit more three-dimensional. The 2 carbons are in a line, and then the oxygens around kind of actually line up in little kind of pyramids off here and a pyramid off here in different directions like that. And these bonds couldn't twist and rotate in the ball and stick models, and in real life they actually can too. So this would be C2H6 in the structure in the model kit, and then this would be the flat structure of it, but each of them show what's connected to what. Okay, I think I'll do one more example here, and that's C2H4, because we're going to bring a new trick into the scheme here. So 2 times 4 would be 8 electrons, and 4 times 1 is 4, so there's only 12 electrons this time. Well, I think I got to start out the same way. I'm going to do my carbon and do 1, 2, 3, 4. And then I'm going to do a different carbon, and we'll get a different marker for that. And I'm going to go carbon. Remember, hydrogen can't be the cheese, so I'm going to do that last. And 1, 2, 3, 4, like this. I'm looking at this, and I got 4 hydrogens, but yet I have 1, 2, 3, 4, 5, 6 blank spots. So we got a little bit of a problem that we're going to have to resolve, but let's fill in some of our hydrogens. But I'm going to be a little bit more careful and keep it symmetrical. What I do to one side, I'll do to the other side. I'll put a hydrogen here, and then I'll put a hydrogen on this one. It doesn't really matter if you look at this in 3D, but this is what we'll end up doing, okay? Now I'm going to take another hydrogen here and put one here. It's an electron dot, if you couldn't tell what that was, okay? Then I'm going to take another hydrogen and put it here. And I'm going to look at my rules because I think I have a little bit of a problem. I have 2, 4, 6, 8, 10, 11, 12. I match up my electrons. There's 2 around each hydrogen, but there's 2, 4, 6, 7 around this carbon. 2, 4, 6, 7. There's just not enough sharing. We need to get to 8 electrons. So we need to do some more sharing. Okay, you might know where this is going, but let's look at our rules. Make sure we're following those. A shortage of electrons, which is what we have, usually means a double bond, or if you try a double bond and it's still short, then you have to go to a triple bond. Okay, so that's what we're going to do, is go to a double bond right here. So instead of the 2 carbons sharing just 1 electron each, they're going to share 2 electrons each. So I'm just going to move these electrons. It doesn't really matter what color they are. I'm going to get rid of them here. And then maybe I'll just put them in a new color just to be whatever. And I'm going to move them up here. And like this. And this right between them. Okay, so I look here and I have a carbon. I have 2, 4, 6, 8, 10, 12 total electrons, which we want. Now I have 2, 4, 6, 8 around this carbon and 2, 4, 6, 8 around this carbon. So I match it up. So if you're short of electrons, you put everything out, then you need to do multiple bonds. Try doubling it. If you're still short, then try a triple bond. What's going to happen, the CH and the CC are going to be exactly the same as before. So I'll just draw an arrow down, no need to mess with it. What does this double bond look like? It actually, we put in the 2 springs, it allows us to connect these things. It looks something like this, okay? Let's see, how many bonded electron pairs do we have this time? Well, 12 divided by 2 would be 6, so it's 1, 2, 3, 4, 5, 6, so the double bond counts as 2, and there's no unbonded electron pairs on things. All right, so this is an example of a double bond. I think occasionally you'll see a couple double and triple bonds in this last page right here. Some single bonds, some double bonds, some triple bonds here. All right, good luck, practice these, check over keys. Let me know what questions you have as you practice these.